Good afternoon, everyone, and welcome to your course on Big Data. Wishing you all a very happy new year. We are waiting for ma'am to join in. So, as soon as she joins in, then we'll start with the course. First, with your doubts from yesterday's lecture, and then with the next topic that is to be covered. So, as soon as she joins in, we'll start with the next part of the course.
Okay, ma'am.
Okay. Good evening, ma'am.
Good evening, ma'am.
A very happy new year to you.
Happy New Year to all of you. Thank you, ma'am.
So, I have shared their yesterday's script to them.
Okay, ma'am.
So, we can start with the course now.
Yeah, sure, ma'am. Sure.
Okay, ma'am.
So, very good evening to all the students. So, I hope you people were able to try the concepts that we have learned yesterday regarding the data frames and how we can perform various, structured query language commands. As some of the students were not aware of SQL commands. So, in case if there is any query, you may please ask. Yes, students?
No, ma'am, no query.
So, kindly convey, is my screen visible?
Yes, ma'am.
Yes, ma'am.
We are briefly going to cover about the files and how to import them. Fine, students? So, as we have already discussed that when we are doing any kind of analysis, whether it is a R programming language or Python programming language, so there is always a requirement to have our data. And in order to, take the data for analysis purpose, we have learned various methods, and few of them you are already aware of. Could you please share with me till now how we have used data or how you have stored that?
We have used built-in data sets and created some data sets on our own.
Yeah. So we haven't tried till now how we can, import data from the files. Fine, students. So I have shown you one example yesterday to read the CSV file. So you can go about reading different kind of file formats using our programming so that you can carry out analysis for either prediction of something or for simply some kind of exploratory data analysis using the data contained in those files. So these are some of the data sets which are available and that you can use. I hope all of you have tried the command that I have told you in order to explore. So could you please share with me what is that command through which you can know what are the available data sets?
Data?
No. Anyone else? Please check it out. How you explore data sets?
Data?
Data command is used to display the data of a particular data set. My query is somewhat different. How you can know that these data sets are present in your machine? So how you will explore this thing?
Help.
Help about what? Yes, students.
Ma'am, I have checked. It's data command for that.
It's data command. Sure?
Yes, ma'am.
Yes, ma'am,
Yes,
it's
ma'am.
data.
Only data? Like this?
Data, no, ma'am. Data
Parenthesis?
function. It's like with parentheses. Yes, ma'am.
Okay. And what do you come to know about data sets? Is there anything like data sets? Data sets package? Is there any command like data sets? So it's not showing any data in this. Okay. So now after knowing all this data, so how you will first of all check the structure of all these data? What is the command for that? In order to check
str,
the
then
structure?
parentheses.
STR.
Good. So students, like we people have done different things on the inbuilt data sets which are already available in your, you can say, R programming. So you can first of all explore the list of data sets available. Then you can explore the structure of any of the data sets, and you can also explore the information about the data sets by using the command help. So this much is essential. So let's say in case if you want to explore something about import. So could you please try the command? So we are going to have this command which is read.csv. Fine, students. So read.csv is basically a command in order to read a file. So in this you will have to pass certain things like you will have to tell the location of the file first of all, and another thing that I have told is header argument. So I hope you remember yesterday we tried to read one file. Yes, students. So here is the command. So for this, we need to first of all check whether this path is correct or not. Fine, students. So in case if it is not working, so you will have to mention specifically the path of this particular file. So you please try to find out, okay, first of all, you construct a file on your desktop with, simple attributes. These can be simple serial number, name, fine, students. Only and subject marks or percentage. So please create this file. So under this you create some data. So after this you may please save this file. Suppose we are going to save it in directly H drive, and I am giving it some name. Let's say test marks. Fine, students. So we are just saving this as an Excel file. or you can also save save it as an .csv file. So for that you will have to again save it. Again in H drive we are saving it with the name, let's say test marks 1, and from here you just check it out, .csv file format, comma separated file. Fine, students? So just go to the particular folder where you have saved all these files. So these are in H drive. And we have named them with so here there is one file with the name test marks. So all the files, this name will appear before you, and you will have to just identify. Let me give the full name so that rest of the options will go. Test marks dot xlsx. Fine, students. So it will just give you the complete path of that file. And if you are looking for your CSV file, then you please give the name of that CSV file. So all your CSV files will appear with this, A written at the bottom right corner. So if you're not getting this, means it's not a CSV file. So you can check it out which CSV files are present with you, or any kind of Excel file, because the current file I have saved with both the names. So this file, one more file which I'm using is onion production. It is here basically in this file format, which is showing the onion production basically in different years. So what we can do, we can just copy this syntax which is available, and you can paste it in the location where you want to put this. So it is in H folder. So all of you, I hope, can see the location provided here. Fine, students. So you will have to copy this, and name of the file is onion underscore production. So we are going back to the R file, and it is provided here onion underscore production. So for this, actually, the path is not provided. That's why it is not giving us the proper data. Okay, students. So then you can just display the information of this variable, which is BM. Is it clear to all of you? Yes, students? Is this step clear to all of you? I have used the function read.csv. Fine. And it is, present file location we have used is onion_production is the file name, and it is available in the particular folder with the name H and then Python for data analytics. Fine, students. So you will have to execute the complete path in order to open the file in our platform. Please convey if you are able to open the file. The method name is read.csv.
Excuse me, ma'am.
Yeah,
Can you again show the command?
sure. So BM is nothing but it is simply a variable name. Data I'm fetching, I'm passing this to this variable, or you can say handler. The method name is read.csv. Fine, students. So in this, the first argument that I'm passing is the path of the file. So I have shown you that this particular file is present in this particular directory. Just I have reversed the direction of this slash. Fine, students. So when you will copy the path from the properties of that particular file, the slash direction will be different. So just reverse it, and then you can just put this header equals to true. Fine, students. So header
Yes, ma'am.
equals to true means it will show all the column headings. And then I have mentioned that as it is a CSV file, so my file is having separator as comma. So as the name itself tells you, comma separated file means the different values in different rows are separated by the delimiter comma. You can even make use of some other delimiter. So here the separator is comma. So I'm mentioning that in SEP argument. Fine, students. So main thing is file path. Then string as factors equals to false. This we have set here. So once you have done, then I have simply, displayed the value of this particular BM variable. Or you can even use this view BM. So this is the information that is available in your file with this name. Fine. So I just showed you one particular, file in Excel as well as CSV. The Excel file which we have just created. So could you please repeat the same for this file? Yes, students. This file,
Yes, ma'am.
try to open it so that you will come to know whether it is working or not. Please convey once you have done with this.
Done, ma'am.
Okay, so now we are moving ahead. So once we have done with this, so it means we are able to open the particular CSV file that we wanted to open. And only thing that we have set is the header equals to true. So now I'm going to tell you one more command, that is read.table command. Fine, students? Read.table command. So this also you can use, and you can set the argument to true, and this indicates that the first row of the data set contains the variable names, and you can have this separator argument also, which you can set. So please make use of the command read.table, and then rest of the things are same. Fine, students? So just come back to our studio. Okay, please repeat the same. So rather than using this read, make use of read.table. Just check it. Is it working for you?
Yes, ma'am.
Yes, students, is it working for all of you? Read.table.
Yeah.
So what you are getting? So read.table is basically to open in the form of tabular structure. So you can just pass this command for displaying all the details. Fine, students. So you can even use a tab as a separator. Just make use of in place of comma tab. Are you able to see this? Separator equals to /t within double quotes. So what it will do, it will simply display all the values separated by tab. Fine, students. So similarly, in order to import your Excel file, so just put this formula read.xls, then the file name within double quotes and sheet index equals to 1. Because usually Excel file is consisted of many sheets. So you will have to mention the sheet index also. Are you getting this point, students?
Yes, ma'am.
Read.xlx, then mention the name of the file. You can even put the file name which you have just created, and then sheet index. Just find out what is the sheet index set, and try to run this command. So this is the file. You can check for the properties. So from properties, as it is directly available in this, so just you will have to copy this, come back to your this. So here you can provide some name to the handler. And within this, just within double quotes, mention the path. And the name of our file is test marks dot, because it is case sensitive, so just take care of the file name properly. Test marks. Fine, students. And what was the second argument? We have simply used, either you can keep the header as true, and sheet index is must. Sheet index equals to 1. I is capital and S is small.
Ma'am, it's error.
It's giving error. What
Yes,
is
ma'am.
that
Yes,
error?
function not found. Function not found. Read.xlsx.
Okay. Another one is working for you. Read.csv is working.
Yeah, CSV and dot table was working.
Okay, fine. So now do one thing. There is a package with the name XLSX. Fine, students. Just check it out whether this package is available or not. I hope now you can just explore on your own. Check it out whether this package is there or not, and if not, then you can please just install the package. Are you getting this thing?
Yes, ma'am.
XLSX. Please install this package. And then check it out whether it is working or not. Fine, student. So before this, I am passing this command library. And within parentheses, again specify the name. Is it working on your system? Please check it out.
Ma'am, it's installing that package.
Okay. So always for run what function you require a particular package first. So earlier worked without any extra package, but in order to access this particular file or method, you need to use this particular package with this name. Fine, students? Similarly, we are using read.spss in order to read any file from your SPSS. It's again a statistical, package for doing the analysis. So that also you can open in R. And for this you require foreign package with the name foreign.
Maybe you can use read underscore Excel or read underscore Excel S6.
Yes, students, is it working?
Yes, ma'am, it's installed.
What about other students? Are you able to open the file? And similarly, if we want to write something into the file, then we will have to run the command write.csv. So we have earlier, opened the file with the name onion underscore production.csv. So that is read.csv. And in order to write the information into that, you will have to simply specify the method write.csv. Fine. And here, suppose you are having some variable in which information is there. So write that into the file. So this is the thing that we are doing with the help of write.csv. Fine, students? Please convey if you have done with this.
Ma'am, please repeat the steps after installing Excel exec file.
Then you will have to use the particular package. Always the steps are same, whether it is any package. So first of all, if your function is not working, so first of all, you you will have to check which package is required in order to run that function. So then install that particular package, and then by using the command library, you use or load that particular package into your R. Fine, students? And then you can use that function. So these are the steps.
Okay, ma'am.
So you can always work with set working directory also. So I had told you this command earlier also. Suppose while using this kind of file related functions, you are facing problem. So what you can do, you can simply set the working directory so that by default your files will be written into that and you will read the files from that. So after setting the working directory, you can simply mention the name of the file within double quotes. Okay, students? Otherwise, what you need, you will have to specify the file total location. So it is in H drive or C drive or D drive, then followed by folder name. So you will have to give the absolute path. And after identifying that this directory want to make, present working directory, so you can just pass this command, set working directory. Fine, students? You can make any directory as current working directory. Just try to run this command. So, so for that, first of all, you create a folder with your name. Let's say in C drive, you created a folder with your name. Just give the name of that particular directory or root in the set working directory method. Fine, students? So you can set the working directory, then after that, it will be easier for you. So now the file which you have retrieved, you can just work like as we work with data frames. Fine, students? So you can just run head command also, like here we have run. There is a file with name carspeeds.csv. So can you please repeat head command on the file that you have just read? Yes, students? Can you run the head command on that?
Yes, ma'am.
Just check it out. Means right now we are working with file. Fine, students. So as the number of columns are quite high in my case, so that's why it's showing the output like this. But if your file is having very less number of, columns, so it will simply show you properly. So you can run a head command also like we perform on data frames. And similarly, you can try out by, fetching the data from that particular file. So currently, as I have stored it in BM variable, so you can please try out whether it is working or how you can fetch rows and columns. Okay, students. So any kind of, method that you have run on matrices, that will work here also. Fine, students. So I have extracted the information from the file in first row, second column. Please try it out. Are you able to fetch data from the file? So in my case, it is corresponding to, this is my column number 1 and 41.66 is my second column data in first row. Fine, students? Please convey if you are able to do.
Yes, ma'am. Done.
So just take care that the file path should be proper. Fine, students? So if your file path is correct, then it's okay. Otherwise, what you can do, you can simply set the working directory. If you are saving your all files into one particular folder, so set that as the current working directory. So in that case, within double quotes, just mention the file name. Fine? Other than giving the complete path. So you can also put a condition that we have learned. Please try to apply this statement if else. Yes, students, please try to apply this statement on any of column that you are just using in your file. I'm showing it in the notepad. So will you please tell what is the name of any column that you want to try? Which file you are using? Yes, students? Which file you are using currently?
Ma'am, our files are different from your files
Okay.
actually.
So is this condition working for all of you? You can put any condition on any column. If else is the syntax. So you will have to mention the name of the variable in which your file is stored. Then after dollar, mention the column name. Fine, students. And then equals to symbol means I'm checking for some condition where value equals to suppose this. And then you will have to mention so it will just show you the output once you are just retrieving. So if you are not working with this, then you can just make use of any column that you are specifying. Fine, students. So we are now moving towards another thing that you can try out. Yes. Yes, students. So we are going to make use of one another data set that is chick weights. I hope it is visible to all of you. So first of all, explore the structure of this chick weights. Then attach this particular data set. And then compute mean upon that. Fine, students? So we are computing mean on the weight variable. So this is a kind of exploration where you people can just find out on a particular column, a particular attribute, some kind of computations. These kind of computations are coming under measures of central tendency. So when one value you want to convey in order to interpret something, then you can make use of either mean, median, or mode. So these kind of statistics you can compute on any particular data set. Fine, students? Is it working for you? First of all, you go for STR chick weights. So it is having 71 observations of 2 variables. And then we are computing mean on WEI GHT weight attribute. Not applicable. It is, I think, weight only. We'll have to by about the different attribute. So it will show you the mean value for the weight attribute in this particular data frame. So could you share with me what does a mean conveys and what kind of restrictions are there? Yes, students? Is mean a right kind of measure which conveys the information correctly, or is there any kind of flaw in this? Have you read about mean or average? Yes, students.
Yes, ma'am.
So what is the difference between mean and median? Yes, students. What is the difference between mean and median?
Ma'am, mean is computed by all the values by taking the kind of average, whereas median is only the
Okay.
single value which is present in between by sorting the data.
Okay, the data needs to be sorted and middle value represents the median, or you say if it is a kind of, odd number of values, then middle 2 values average can be taken. So which one is better, median or mean?
Ma'am, mean maybe.
Any other student?
Yes, ma'am. Mean
Which
is better.
measure of central tendency is better, mean or median?
Mean.
Mean. So what if your data includes some values that are in extremes? Suppose you are 100 students in a class, fine. So most the marks of all students are okay, but there are few students who have achieved either very less marks out of 100 or they have achieved very high marks. Are you getting me? So in such cases, mean is not going to represent the central value of your data. You need to understand all these aspects. Mean is of importance when your data is normally distributed. Mostly all students' data is nearby. So if there are many students with extreme values, so that will deviate the final central value that you will get. And similarly, you can go for median computation if you feel that middle value represents most of the values in your data. Fine, students? So it depends upon situation what kind of data you have. So just take care that if your data is having some kind of extreme values, then mean will not be a suitable choice. And what do you understand by mode? Yes, students? If I'm having this set of values, can you compute mode of this? Students, can you compute mode out of this?
6.
Mode.
Ma'am,
What is the
highest
definition for?
frequency.
So what kind of data you require for computing the mode?
Similar type of data.
Say for example, here I am having some set of observations. Fine. So here I can compute the frequency. 2 is repeated how many times? In this
One.
data, 2 is only coming once. What about 3? 3 also
One.
once. What about 4? 4 is coming twice. 5 is coming once. 6 is coming twice. Sorry, thrice. 8 is again getting repeated just once, and 9 also once. So if somebody asks me that what is the mode of this particular data, fine students, so we will reply that 3 is the mode because, sorry, this 6 is the mode because 6 is repeated thrice. So the maximum number of times the number which is getting repeated is 6 because its frequency is high. Highest frequency element is your mode. Fine, students? Is it clear to all? The
Yes,
meaning
ma'am.
of mode? So mode is the kind of measure of central tendency for the nominal data. So here on check weights, we have applied to compute the mean first of all, then you can simply compute median also, and you can see the difference that if I am computing here median on the same data set on the weight attribute, so its value will be different. Fine, students? So mean is 261.3099 and median is 258. So both figures are varying from each other. So now in R, if somebody asks you to compute mode as such, there is no direct way of computing this. So first of all, you need to create a frequency table, like as I have just explained you, that if you are provided with data, first of all, create a frequency table of each number and then find the highest frequency and define the corresponding value or category as the mode. Fine, students? So you will have to compute that which particular category or value is getting repeated highest time. Like in my case, it was not kind of, you can say, category. Fine, students? So it was simply value based data. Values were different. So we just checked that which value is getting repeated how many times. So sometimes it can be category also. Suppose 100 students are divided into 4 groups, A, B, C, D. And in, along with every student name, I am mentioning the group. So if out of 100 students, group A students are 20, group B students are 40, group 3 C students are again 20, and group 4 students or D students are again 20. So could you please tell me which particular group is of the highest frequency? 20, 40, 20, 20. A, B, C, D, there are 4 group of students. So I have just assigned the group name to each and every student in the data set. Fine, students? So for this, there is as such no direct command. So you will have to first compute, this, frequency table. So for that, there is a command with the name table on the particular field. So you can first check it out. What is the values in this particular? Can you see the data which is very with respect to the third, attribute, that is feed. So this kind of, attribute where the values are of different categories and they are getting repeated. So I can just count the frequency table. Okay, in these many records, horse bean is there. And then linseed is there in these many records. Fine, students, and soybean is available, sunflower, so meat, meal. These are the different categories in the feed attribute of chickweight's dataset. So you need to have either this kind of, attribute where there are different kind of categories. Only then you can compute the mode. Fine, students. So just pass the command tab equals to table, and within this feed. Feed is the name of the attribute I have just shown you. Are you getting this kind of data? Please check it out. So I have created a frequency table.
दोबारा join करता हूँ.
So we have created a frequency table over here in which I am having corresponding to different classes or categories in this particular attribute with the name feed. So 12, 12, 11, 14, 12. So I'm expecting that the highest frequency is for soybean. So fine. So you need to now display the value corresponding to this. This particular item is basically having high frequency. This is my main objective. So after computation of frequency table using the table command, syntax is very simple. Tab is simply a variable. Table is the command in which you will have to pass this kind of attribute which is having different classes, or if it is a numeric value, then the values are getting repeated. Fine, students? So now run this command. So what I have done, I have computed what is the name of that highest frequency item in the attribute feed. Fine, student? So for this, you will have to first of all check tab equals to maximum of tab. Out of this tab variable, which value is maximum? So what it will do, it will simply fetch this 14 value. Fine, and it will assign to this variable tab. And then I'm checking names tab. What is the name corresponding to that highest frequency item? So when we are trying to display the name corresponding to this highest frequency item, so it will just display this column name, soybean. Is it clear to all of you? So please check it out if you are able to do this.
Yes, ma'am.
So as I said, Happy New Year. Fine, student. So actually there is no direct command. So I'm just showing you again how we have done this. So first of all, my main requirement for computing mode is to have some attribute which is of type different classes. Fine, students. So for this, we have used this particular data set, chickweight's. And after exploring the data, I came to know that feed is the attribute which is having data of different categories. Fine. So now I want to first of all compute the frequency, and for that make use of table command and give the attribute name. It will just compute the frequency for these different categories in this column. And now we can simply pass this command. Name tab means just extract the name of this particular. This is the common command. We have done it for data frames also. So names of tab means in this particular data table, what is the name for this frequency item? Students, kindly convey, are you able to do this?
Yes, ma'am.
So is it visible to all of you students?
Yes, ma'am.
Yes.
So next we are going to do, now we understand what is this mean and median and mode. Similarly, you can also compute some other measures of central tendency which are needed for understanding your probability distributions. Fine, students? So there is another kind of, measure that is known as measure of dispersion. So say for example, we are having this set of values, variable 1 and variable 2. So both of these, set of values are having the same mean, which is equal to 5. So what we are going to say over here is the point is the two variables which are having different set of values have the same central tendency, that is mean, but they have different variability or the dispersion or spread. So how your values are spreaded between this, that part is different. So you can look at these values from here that even if the mean of both of these set of data is same, but the dispersion is different. So in order to have this kind of, computation, we have certain other measures. And one of them is, a calculation of mean deviation, or you can say average deviation, and variance and standard deviation. And we can also compute that what is the dispersion rate by calculating the range. So these are the three measures of dispersion. You can say the easiest one is range. Fine, students? Or you can say how your data is scattered. Fine. So in order to compute, we'll have to make use of three kind of measures of dispersion. So first of all, we are talking about range, which is generally computed by calculating the difference between maximum and minimum range of values. So we are having here one field which is with respect to the weight. So you can simply check it out. What is the range for weight? Range is generally the difference between the maximum and minimum value in a particular column or particular attribute. Yes, students, please check it out. Is it working? So in the weight attribute, having minimum value as 108 and maximum value is 423. So rest of the values are scattered between these two values. So this is the, you can say, the range which is giving you an idea about dispersion of your data in a particular variable or attribute. Yes, students, are you able to do this?
Yes, ma'am.
So this is the easiest, this is the easiest idea about the range of numbers you are having in a particular. Same you can apply with marks. Suppose you are having a data set which is having the student marks. So you can compute on that this range. So you will come to know that the marks of the students are varying between these two numbers. Fine, students? Similarly, you can also compute variance. Have you read about these terms like standard deviation and variance earlier? Yes, students.
Yes, ma'am.
Yes, ma'am.
Fine. So if you have read, then simply in R you need to know. Basically, all the programming languages like we are doing it in R. So they are having very, very easy commands for processing the complete things. So before you apply any one of them, like I'm showing you here, the simple command is a VAR command and SD command. VAR is for variance and SD for standard deviation. So you can simply run on this weight and you will come to know that it's so easy. Fine, students. So if you understand the concept basically, then simply you need to know the function name. In R, all such kind of things are pre-programmed. So is it working for all of you?
Done, ma'am.
Range command, standard deviation,
Yes.
and variance.
Yes, ma'am.
So here you can understand that before we proceed with any kind of distribution, you need to understand what does this term describes. A probability distribution describes how the values of a random variable is distributed. Fine, students. Say for example, we are having a collection of all possible outcomes of a sequence of coin tossing. This is very common example when you start with studying probability and probability distributions. So have you heard of this coin tossing example in probability?
Yes, ma'am.
So
Yes.
will you, so kindly share with me, what is the probability of getting head and tail?
0.5.
0.5.
0.5. So it means for every event, we are having 1 by 2 probability and the sum of that is 1. So binomial distribution means when we are having only 2 possibilities. So for any sequence of coin tossing, suppose you are tossing the coin 10 times. Fine, students, and every time either you will get head or you will get tail. So it is going to be head, tail, or tail, tail. Only one out of the 2 outcomes will be there in the success. So you can apply the first, you can say, probability distribution, which is of the kind of binomial distribution, as followed by the coin tossing example. So similarly, in different kind of events, different kind of distributions are exhibited by the data. So these are some of the distributions. So out of this, we will try to cover the starting 3-4 so that you can understand the concept of probability distributions and how in R it is available. Fine, students. So the first one, binomial distribution, it is applied to a discrete probability distribution, and it describes the outcome of n independent trials in an experiment. So what do you understand? Independent and dependent. Yes, students?
Independent means the result is not dependent on the number of terms we are.
The result is not dependent upon some other event. So all the events that you are performing or occurrence of different trials are independent in nature. So it describes that the outcome of n independent trials in an experiment. Each trial is assumed to have only two outcomes, and we will say success or failure. If the probability of a successful trial we are taking as P, then what will be the probability of unsuccessful trial? Yes, students? If the success probability is P, then what will be the probability of getting, failure? One minus P, good. So then the probability of having X successful outcomes we are going to compute in an independent trial. So here you need to understand that total number of trials are N. Probability of getting success in a trial is P. Probability of getting, failure is 1 minus P. And I am interested in finding out the probability of having X number of successful outcomes. So it means, suppose if I expect that if I get head, then only success. Fine, student. So I'm designating success for getting, head in the coin tossing. So, and if I ask you how many times out of 10 independent trials you are getting head, fine, students. So I want to compute the probability of getting head. Let's say 5 times, 5 number of times. So you can compute the probability where the total number of outcomes are going to be of two types, success or failure. So this is the formula for binomial distribution. You might have read this in your stats. So have you gone through statistical concepts in your BTech or earlier in 12th or so? Yes, what is your response?
In 12th, ma'am.
In 12th, so good. So I hope now you have understood the different variables in the formula. P is the probability of getting success, and I am interested in computing the probability where I want to check it for X number of times getting success. And if 1 minus P is the probability of getting failure, so number of times I will get failure is N minus X. N minus X and X is the number of times that event is occurring. Success and failure. Fine, students? So you can compute this particular kind of probability distribution for any number of value for X, depending upon the number of trials that you're going to perform. Fine, students? So I'm showing before you one simple problem. Suppose there are 12 multiple choice questions in an English class quiz. So each question has 5 possible answers and only one of them is correct. Fine, students? It is just like kind of MCQ. So you are having how many multiple choice questions? 12 in a particular subject quiz. And each question is having 5 possible answers. And out of 5 possible answers, only one choice is correct and rest are, you can say, incorrect. So find the probability of having 4 or less correct answers if a student attempts to answer every question at random. So this is the question. Fine, students? So since only 1 out of 5 possible answers is correct, the probability of answering a question correctly by random is 1 upon 5, or you can say 0.2. So you can find out the probability of having exactly 4 correct answers by random attempts by using this particular formula, which is shown here. The formula which we just seen for this binomial distribution in R programming, this is the simple, name of the function which computes for you binomial distribution. Fine, students? So as I am interested in computing the 4 correct answers, so this starting 4 value is the 4 correct answers, and size means equals to 12. It is corresponding to number of possible tries out of which you are going to. So there are total 12 questions, out of which I'm looking for am I getting 4 correct answers if I attempt these 12 questions at random, and probability of getting success is 0.2. So suppose if luckily you have clicked on the correct answer, so probability of success is also 0. Probability of failure is also 0.2. Okay, students? Not to do any hard job, so simply you need to know this name. This is for binomial distribution, and you can just apply according to your requirement. So just as in this example, we have seen that if you are interested in computing the success probability for 4 correct answers out of 12, so simply apply this formula and you will get. Okay, friends? So kindly check, is it working for you to pass these values? Yes, students? And if you are not aware of these kind of functions, so you can just check the help on distributions. I have already, opened this help file over here. So you can simply check it out. These are the different, distributions. These are available in the stats package. Fine, students. So like for binomial distribution, you have D binom. Similarly, for chi-square distribution, you have another function. So first of all, you need to understand what kind of probability distribution you want to compute. Yes, students, please convey me. Are you able to do this?
Yes, ma'am.
Yes, ma'am.
So next, it's working. So you just understand the meaning of the argument, how you want to pass the different argument values. So now next question is, find out the probability of having 4 or less correct answers. Fine, students? 4 or less answers. So you can perform the, you can attempt the questions randomly. You can even perform, let's say, question number 12 first, then 5th, and then first. The sequence may be any. So at random, you can perform the questions, but my main requirement is to find out the probability of getting 4 or less correct answers. So again, as in this case also, I need to do some additional part, because now not only for this 4 correct answers, I want to know what is the probability of getting 3 correct answers out of 12 with success probability 0.2. Similarly, probability of getting 2 correct answers, 1 correct answers, and none. Fine, students. So when it is a matter of getting 4 or less correct answers out of 12 MCQ questions, you will have to compute all these probability. The sum of all these is your answer. Yes, students, please run this command and tell me if you are getting the same. So if you have done all these distributions in your BTech, then it is easier. So just pass this in above, because here it may create some kind of.
It's working, ma'am.
It's working.
Yes, ma'am.
Because here some additional characters were coming, that's why it gave error message.
Done, ma'am.
Good. What about other students? Is the meaning of binomial distribution is clear to all of you? Then only it is useful.
Yes, ma'am.
So if you don't understand binomial distribution, so I request you to please go through first, what is the meaning of this binomial distribution in detail, perform some, manual questions. I hope you might have done all this in probability and statistics in your 12th level. So that's why I have taken up this distribution so that you can understand how we can perform it in our language. So you can understand here that here we are not, mentioning in detail, just you need to know the function name and some arguments. So if that also is not clear to you, then you can simply check the help file. Fine, students? So what about rest of the students? Are you able to do this command? Okay, now, so another alternate. So as you have seen that here I have mentioned, addition of lot many these, 0, 1, 2, 3, 4, 5, 5 times I have repeated this binomial distribution function in order to compute the probability requirement for 4 or less correct answers. So in place of this, you can go for cumulative probability function for binomial distribution, and this is with the name P binom. Fine, students? So you can compute P binom, and in this you can pass 4. You're interested in getting 4 or less. So it will automatically compute this above, cumulative. Size equals to 12 and probability 0.2. So as I'm getting the same answer, 0.927444. So just, calculate the percentage of this. So it is going to be 92.7%. The probability of 4 or less questions answered correctly by random in out of 12 questions is 92.7%. Fine, students? So this is the probability of getting 4 or less correct answers. Please run this also, P binom.
Done, ma'am.
Done, ma'am.
Okay, then we are moving to the next one. So it is your Poisson distribution. This is, it computes the probability distribution of independent event occurrences in an interval. So here we are going to correlate something with respect to interval. So if lambda is the mean occurrence per interval, then the probability of having x occurrences within a given interval can be computed using this Poisson distribution formula. F of x equals to lambda raised to power x into e raised to power minus lambda divided by x factorial, where x can have any value depending upon your requirement of x occurrences. Fine, students? So you will be provided with mean occurrence per interval. Fine, students? So your data will be in intervals, and you will have to tell what is the mean occurrence per interval. And then for any value of x number of occurrences, you can compute the probability. So this is going to be the formula if you do it manually. I hope you might have done many numericals of such type with respect to Poisson distribution. Yes, students, please convey. So when you do it, manually, then you will have to apply this formula. You need to know this mean value of occurrence per interval, and how many number of occurrences you want to compute, you can then put here. Fine. And after substitution, you will get the final result. So we are going to do it for the given problem. So if there are 12 cars crossing a bridge per minute on an average, fine, students. So how many cars are crossing a bridge per minute is 12. So we need to find out the probability of having 17 or more cars crossing the bridge in a particular minute. So here interval is what? Interval is we are talking about per minute. Fine, students? So per minute, what is the probability of having 17 or more cars crossing the bridge? And I'm provided with that 12 is the average value with respect to number of cars crossing the bridge. So the probability 16 or less cars crossing the bridge in a particular minute is given by the function POIS for Poisson distribution, probability distribution, POIS for Poisson and P for probability distribution. Fine. So for this, you are having in R this function PPOIS. So I'm putting here 16. Lambda is the value which I have just told you, mean value or average value of occurrence per interval. So it is given to us that 12 number of cars are crossing on an average per minute. Fine, students. So this is lambda is given to me, and 16 I'm calculating that what is the probability of 16 cars crossing the bridge. Fine, students. So you can compute this particular function, and here you can see that for probability of having 17 or more cars crossing the bridge in a minute is in the upper tail of the probability density function. So now you can compute the same by putting the value here where lower equals to false, because our aim is to compute 17 or more. Fine, students. So this is the lower bound kind of thing. So you will have to put this argument equals to false, because we want to compute it for upper side 17 and above. So put this lower argument equals to false. Lambda means the value given to you 12, and 16 is the value for the lower. Fine, students. So if you will put this value, then you will be able to tell that what is going to be the probability here. So if there are 12 cars crossing a bridge per minute on an average, the probability of having 17 or more crossing the bridge in a particular minute is 10.1%. Fine, students. So please run it and tell me whether you are getting a reply or not. So here main thing is not the function, but to understand the problem. Fine, students. So if it is a matter of, computing 16 cars crossing, then you will have to run the above. And this is lambda value. And if it is 17 and above, then you will have to put this argument equals to false, because we will have to compute the upper bound for that. 17 and above के लिए आपको total probability you will have to compute. Students? Shall I proceed further? Please convey. Are you able to run this or not?
Done, ma'am.
Done.
What about other students? So it will simply give you this value, and for the second case 17 and above, just set the value of lower equals to false. So lower equals to false simply conveys that we are interested in upper tail. Fine, students, and then compute percentage. It is 10.1%. Now we're moving to the next distribution. It is continuous uniform distribution. So in continuous uniform distribution, it is the probability distribution of random number selection from the continuous interval between A and B. So density function is computed by the following definition, which is given here. If the value of some random variable between A and B, you compute this continuous uniform distribution value 1 upon b minus a, and if the value of x is less than a and greater than this limit b, then it is going to be 0. Fine, students. So suppose we are having a problem that select 10 random numbers between 1 and 3. Fine, students. So our requirement is to select 10 random numbers between 1 and 3. For this, we apply the generation function RUNIF. Students, RUNIF. It is meant for uniform distribution to generate the random numbers between 1 and 3. So in this particular function, run if, pass how many numbers you want to generate, it is 10. And what is the minimum and maximum value between which you want to? So just from this formula, I'm telling you, x is what and a and b is what. Fine, students. So whatsoever random number x you are generating, it should be between a and b. Fine, students. So I'm mentioning the values for a and b over here, that I want to generate 10 random numbers between 1 and 3. So simply run this command and you will get. Okay, students.
Done, ma'am.
So what if you want to generate 100 numbers between 1 and 10? Check the command. What you will do now? How you will manipulate? Question is to generate 100 numbers between 1 and 10. So here you need to specify how many numbers you want to generate. Minimum equals to 1, maximum equals to 10. Fine, students. So we have generated random numbers and we call it continuous uniform distribution. Fine, students. Uniformly, it has generated the numbers between a range. Fine, students. This is the most useful. I hope you have used such kind of feature many times in other programming languages while generating the random numbers. So mostly we work with random numbers in any kind of analysis. So in order to generate a continuous uniform distribution, so suppose you want to generate 100 numbers which exhibit the property of continuous uniform distribution. So what you will do, simply generate these numbers and you can put them in some variable that you can use later on. Fine, students. Rather than writing any number specifically, you can just run this command and save it to some variable. Fine, students. Is it working for you? So please look at this graph. So do you understand the importance of graphical visualization? So if you will plot all these, values, so it will be just, the graph will be like this. So this 1 and 3 on this number line are the range between which we are generating random numbers. Fine, students. And the numbers that we have generated, if I will plot here on x and y axis, so it will just give me this kind of plot. Fine, students.
हाँ कोई दाल दूध बना, दाल में बनाऊंगी क्या पता नहीं ना, बना लूंगी, ये सब खा लेंगे फिर ये भी। तो दाल तो बना
Kindly
लूंगी,
mute the mic, please. Someone's noise is coming.
आटा भिगो दूंगी, आटा तो भिगो दिया रात के नाम का, अभी तो भिगो दिया।
Ankit,
मालूम याद करके देना पड़ेगा।
Ankit, kindly mute your mic. So next is exponential distribution. Fine, students. Exponential distribution describes the arrival time of a randomly recurring independent event sequence. So if mu is the mean waiting time for the next event occurrence, then its probability density function will be expressed by this function f of x is equal to 1 upon mu into e raised to power minus x upon mu. Exponential distribution, where this value of x is greater than equal to 0. And if you are having value for x as less than 0, it will be simply 0. So if you will try to, draw this graph in xy dimensions, so for this you will be having this kind of plot for mu equals to 1. Fine, students? So suppose we are having this example. The mean checkout time of a supermarket cashier is 3 minutes. So find the probability of a customer checkout being completed by the cashier in less than 2 minutes. So this is the question. So in this, the solution will be achieved. The checkout processing rate is equal to 1 divided by the mean checkout completion time. Fine, students? So for each customer, if I want to compute the checkout time, so it depends upon what is the supermarket cashier checkout time. If it is 3, so 1 by 3. So hence the processing rate is 3 checkouts per minute. So by knowing this, you can apply the function PEXP for the exponential distribution. So this is basically rate of checkout. So you will have to mention only two things. This is the name of the function PEXP, and you are told that this you will have to compute for less than 2 minutes. Find the probability of customer checkout being completed by the cashier in less than 2 minutes. Fine, students? So for this is on an average rate of checkout 1 by 3. So by putting this, you can just come to know that the probability of finishing a checkout in under 2 minutes by the cashier is 48.7%. Fine, students? Please run this command and please tell if it is working for you.
Done, ma'am.
Done, ma'am.
Fine, students. So if you are not sure about means what are these different arguments, I request you to please explore their help. Fine, students. So here you can have different examples where you will have to tell the first variable and second variable. First one is for what you want to compute, and the second is always going to be the rate, mean rate. Fine, students. So on an average, if the checkout time is 3 minutes, so rate will be 1 by 3, and here you want to compute for less than 2 minutes. So this is going to be your 48.7% is the probability of getting this. So I hope you all have heard about this last, normal distribution that we are going to do. This is the most common distribution. So if you will go for any kind of data science job or any kind of, machine learning algorithm, so in most of the cases, the data requirement is that the data should be of normal distribution type. And for this, you will have to, this is the formula, standard formula. Fine, students, you will get in any books of probability and statistics. So the normal distribution is defined by the following probability density function, where mu is defined to be the population mean and sigma is the standard variance for this particular population. So I hope you understand that there are some tests which can be conducted on population data and some can be on sample data in order to make the inferences. Fine, students. So here I'm talking about with respect to population, entire data. So what is the population mean? Sigma represents the variance. Fine, students. So this is the formula. You will get it in books. 1 upon sigma into this square root of 2 pi into e raised to power minus x minus mu overall whole square divided by 2 sigma square. Fine, students. So if a random variable x follows this normal distribution, then we, we take this perception that mu is 0 and sigma is 1. Fine, students. This is characteristic of normal distribution. If somebody asks you, please tell us what is the mean of a population which exhibits normal distribution is always it is 0. Fine, students. And this is the variance for the normal distribution. It is 1. And we call it as standard normal distribution if it exhibits this property. Mean 0 and variance 1. And sometimes in you will find this notation also. N 0, 1. And if you will plot the graph, it is normally distributed. So if I will draw a vertical line over here, so you will see that it is a bell-shaped graph. And it is most common distribution which is needed. So along this vertical line, the bell shape, curve will be similar to just copy of each other, mirror image. Fine, students? Yes, students, is this point clear to all of you?
Yes, ma'am.
Okay. Suppose we are going to compute the solution for this given problem. So we are assuming that the test scores of a college entrance exam fits the normal distribution. Are you getting my point? It means they want to say if I plot a graph of this score of a college entrance exam, so it will fit into normal distribution. So furthermore, the mean test score is 72. You are provided with, so the total, college entrance exam, let's say conducted for 100 students. So what will be the size of population? Yes, students? If there are total 100 students who have appeared in the entrance exam. Yes, students? Is my query clear to all of you? So my query is if total number of 100 students are appearing in the entrance exam and I'm maintaining some test scores of all those. So what is the population size in this? If I want to take the scores of all, so population size will be 100 because I'm not taking a sample out of that. I'm trying to do something with respect to all students' test scores. Fine, students. So normally these kind of statistics which we are talking about is with respect to the complete or entire data set. So that's why it is the population mean. So they are saying that suppose if there are 100 students, so the mean test score is 72 given to us, mu value. In the formula, I told you about mu. So mu is 72 given to you, mean test score. And the standard deviation is 15.2. Fine, students? Standard deviation given means sigma. It is 15.2. So what is the percentage of students scoring 84 or more in the exam? So this is the question that we want to compute. So could you please tell me what is the correlation between variance and standard deviation?
The square root.
Yes, students. What it is?
Square root. Square root of variance and standard deviation.
Okay. So just be careful what is given to you. Is the given thing is standard deviation or variance? So as per this, what is your requirement? Sigma represents the variance. Fine, students. So you are provided with what? Standard deviation. Fine. So it means in order to compute variance, what you will do?
You square it.
Okay. So here directly is provided to you, so you can put the value. Fine, students. Standard deviation is 15.2. So in order to solve this question, we are going to apply the function P norm. Fine, students. P norm of the normal distribution with mean 72 and standard deviation 15.2. Fine. Since we are looking for percentage of students scoring higher than 84, so we are interested in upper tail of the normal distribution. Fine, students. 84 and above. So in the P norm function, this 84 is what? Which is my requirement? 84 and above marks in the test exam. Mean marks of students in the test is 72 given to me, and standard deviation is given to me 15.2, and lower dot tail is equal to false. Fine, students? This should be false. So just run this command and tell me whether it is running or not. So I'm getting 0.2149. So it means 21.5% is the probability of getting 84 and above marks in the test.
It's working.
Fine, students. So just to get through this meaning. And if I ask you 84, then you need not to set this lower tail equals to false. Fine, student. So just be careful what is asked in the question. Is it 84 and above means I am talking about 84 and all the above. So it means it is a kind of cumulative. Want to know the test score probability of getting score 84 and above that. So maximum, let's suppose it is 100. So 84 and above all. Fine, students. So for this, you are having this probability distribution function that you know. So next is chi-square distribution. So if x1, x2 up to xm are m independent random variables having the standard normal distribution. I hope now you understand what is the standard normal distribution. Where mean is 0 and variance is 1. Fine, students?
Yes, ma'am.
I just shared with you the definition for normal distribution and when it is called as standard normal distribution. So if your m independent random variables exhibit standard normal distribution, then the following quality follows a chi-square distribution with m degrees of freedom. So its mean is m and variance is 2m. Fine. So here is the formula. For the chi-square distribution with 7 degrees of freedom, and question with respect to question, let us try to understand what is it is. So find the 95th percentile of the chi-square distribution with 7 degrees of freedom. So I want to compute solution for this given problem. So we are going to apply the quantile function QCHISQ. Fine, students. So you will have to apply this function in order to compute your given problem solution using the data which is having standard normal distribution for all these 7 independent variables. Fine, students. These are 7 independent random variables and each one is having standard normal distribution. So they overall will be having chi-square distribution with m degrees of freedom. So let us see. So you can run this command. Please check it out. Is it working or not? Fine, students. So you will be provided with this, how much 95% percentile or how much you need to compute and how many independent variables you have. Accordingly, the value for degree of freedom will be there. So as R is there, you need not to, go in detail, but I request you to first cover all these distributions at your end if you are not clear about these, and then you can simply apply the R function. Fine, students. So this is all the details of this distribution also. So usually these are the very common probability distributions. Further, you can have some other distributions also if you are interested in. You can read about them and you can just explore the corresponding function for that. Okay, students?
Yes.
Yes, ma'am.
Okay, students, if you have any query, you can ask. Otherwise, from my end, the topic is over. So we have to know that as far as probability distribution is there, so many kind of distributions are there. So you will have to first understand the nature of probability distribution you are talking about, what is the requirement for that, and then just look for the help of that particular function in R. Similarly, you can do it in Python also, so the name of the function will be different. Another requirement is in case if it is not working, then look for the package. Because in this case, it's all available in stats package and if it is a part of our basic language, so you don't need to install it. If it is not working, any function, if it is not working, then please first of all install the package from tools along with all the dependencies. Fine, students, and then you can simply use or load. For loading the particular package, there is a library command, and in this manner you can go ahead. Fine.
Yes, ma'am.
So you can take example from my stats book and then you can just check it out. Fine, students. Suppose you have already computed manually some questions of binomial distribution. So now you can just verify your results by using these different methods. So there are lot many other variations also of this probability distributions. Fine, students. So you can just go in detail of these from the help files. So like I am sharing with you this link, so you may please explore. Fine. Yes, students. Fine. So you have lot many other options also. We have done it for P norm, D norm, and several other kind of random distributions you can work around. So best way is to first go through your theoretical aspects. If you're clear about all kind of distributions, then only go for R. because in R you have seen that there is only a single function, just it's a matter of putting the argument values. Okay, students. So now the job is, suppose in future if you do some machine learning job, fine, and if you require some variable to exhibit normal distribution, fine. So you can easily go for checking whether these kind of distributions are followed by the data or not. You can check it out, and then only you can make use of that data for your particular algorithm. So the advantage of knowing about all these distributions is that in order to perform certain advanced level algorithms, you need to understand the nature of the data. Fine. So if your data is proper, then only your results will be correct, or the results that you are expecting. Suppose input requirement is somewhat different and I am just feeding some different data which is not suitable for that algorithm. So definitely even if the steps are correct, but your answer will not be correct that you are expecting out of that. Is this point clear to all of you? Why we go through probability distributions? So you have seen that even we have generated continuous uniform data. 100 numbers we have generated simply using function, and then I have just stored it in a variable and I can work around. So if you have this kind of requirement, you can do this also. Fine, students. So Sakshi ma'am, are you there? Sakshi ma'am, are you there? Yes, students, is there any query from this?
No query, ma'am.
Okay, Sakshi ma'am, are you there? We have finished with the topic scheduled for today, that is probability distributions and how we can go about in R. Okay, students. So I think Sakshi madam is not there.
Ma'am, am I audible now?
Madam, we have covered the scheduled topic
Yes,
about the
ma'am. I was
probability
there only.
distribution.
Maybe
Okay,
my
actually,
mic was no.
okay. I was unable to hear from your side, so that's why I was
Okay.
asking. Yes, madam,
Okay.
you may please ask students. I have asked if there is any query they can ask.
Okay. Fine. So everyone, if you have any doubt, then we can continue with the session. Otherwise, we'll end the session over here for today.
So you can try out the different functions for reading files, and then you can perform your all data analytics that we have covered yesterday also on data frames. So it will behave in the same manner. And rest we have covered about probability distributions and different functions that you can use in R. Fine, students. So from my end, it is final. So thank you all for having patience till end and going through the different topics related to R. So in future also, if any opportunity will be there to interact with you people, so I will be happy to do that. Fine, Sakshi ma'am. So
Okay, fine. Thank you so
can I
much, Sanu
disconnect
ma'am.
now? Okay,
Yes,
thank you,
ma'am.
ma'am.
So
Very
for
much.
your
Will share with
attendance.
you this presentation. They can practice.
Okay, ma'am. Fine.
Fine. Thank you all.
And
Have a nice day and happy new year again. Thank you.
okay, ma'am. So for your attendance, I'll upload that in that link in your chat window only in the WhatsApp group. So for now, we are disconnecting for today. I hope the session was clear to everyone.
Yes, thank you and Happy New Year.
Thank you. Happy New Year to everyone.
New ma'am.